Okay, everyone, good morning. Thank you for working with us through some technical difficulties. My name is Patricia Wyrick, and I am the Rural Forestry Program Coordinator for South Dakota Department of Agriculture and Natural Resources. We are very appreciative to have Kylie Clay from Michigan State University is presenting on carbon products, and I'm really excited about this one. Before we get started, I do have a few housekeeping items to be discussed. Today's workshop will be recorded, with the recordings being placed on the DANR's YouTube channel for public viewing once reviewed and approved by the DANR technical support team. DANR is an equal opportunity provider and wants to encourage participation. However, if you would not like to be part of the live recording, an email with when the recordings are uploaded will be sent to everyone who is registered for this webinar. All microphones and videos have been turned off, and due to the bandwidth concerns, we are requesting I'm sorry, to stay off during the presentation. At the end of the presentation, we will be taking questions. All questions can be placed in the chat box, and/or you can raise your hand to be allowed to turn on your microphone. Anyone seeking Society of American Foresters continuing education credits, please put your information into the chat box during the presentation. Joining us today is Kylie Clay, who is an Associate Director and the U.S.-Canada lead for the Forest Carbon and Climate Program team at Michigan. She has got her PhD in political science from the University of Washington with a focus in the political economy of natural resource governance, and her MS political economy and policy science, London School of Economics. Kylie has her BA in political science and French from the University of Michigan. So with that, you should be able to share your screen, and sorry about the interruption on my end.
Cute interruptions are always desired. Okay, let's see. Which one are we? There we go. That looks like the right one. Okay. Let's make sure this all. Okay, here we go. All right. So hello, everybody. Thanks for having me here. Looking forward to it. I will strive to make this presentation both in the weeds enough to be of interest, but not too in the weeds to be, you know, so nuanced and specific to particular research that it is not of relevance to you. So we'll see what we can do with that objective. So I'll be presenting on carbon and harvested wood products. A little outline here on what we'll be looking at is harvested wood products and carbon storage, just for what that looks like, actual carbon storage and how we think about it, displaced emissions, or substituted emissions for alternative products, which is where we really see harvested wood products having kind of the biggest bang for its buck, let's say. And then the importance of sustainable management and certification in ensuring some of those carbon benefits, in addition to a host of other environmental and social benefits, and a quick discussion on policy and incentive programs to kind of encourage sustainable and efficient harvested wood product use and carbon storage. Come along. Okay, so carbon benefits of wood, of harvested wood products. So, excuse me. First, we'll see. This is a figure from the Forest Service, U.S. Forest Service. You may have seen before. I'll talk you through a little bit what we're looking at here. And this is showing about the narrow view of how we think about carbon in the forest, and then a more comprehensive broad view that includes harvested wood products. So on the left-hand side, can you see my cursor? Anybody?
No,
I have a cursor. No.
But,
no. I'll just try to be as descriptive as I can here as I'm talking. But so on the left-hand side, the left-hand figure, what you see is, if you follow the green kind of mountains there, it's as the timber, as as the trees grow in the forest, carbon accumulates. That's the storage we're looking at. And then as you harvest at year, 37 or so there, that carbon in the forest drops because it's been harvested. And then we see a growth again and harvest and growth and harvest. Right? So that's sort of the traditional view of looking at carbon just in the forest ecosystem. But if we look at this broader view on the right-hand side, which incorporates carbon stored in harvested wood products, we get a slightly different picture. Or you see that same green mountain of harvest, but additionally we see a couple of key components. The first two bars there are represent carbon stored in long-lived wood products and carbon stored in short-lived wood products like pulp and paper. So to focus on those first, that's the actual, what we're talking about there is the actual carbon that stays in the product itself over time. So the fun fact is, I'm sure you've heard, is that 50% of the dry weight of wood is carbon. So as that carbon's still existing in your house and your tables and whatever, that half of the weight of that wood is still carbon. So as long as that product is in use, not being burned or decomposing in a landfill, that carbon is still there, right? So it has not yet been emitted to the atmosphere. So if we can include those bars of long-lived and short-lived products pretty confidently, let's say. That's not based on a host of assumptions about product use. That's based on more physical carbon storage. The next we get to the last two bars, refer to carbon substitution. And we'll talk a little bit more about that in the presentation because that's such an important component, right? So if we look at just the long-lived and short-lived wood products, it's not actually clear that we are above the no harvest scenario, right? And it's with carbon substitution that we really start to see these carbon gains, these relative carbon gains. And that refers to this idea of, again, we'll talk about it later a little bit more, but carbon emitted in the production of other materials, especially concrete and steel, is very high, right? So in any cases that we can substitute for concrete and steel products with harvested wood products, we are essentially saving those carbon emissions. Those substituted carbon emissions, we refer to those as displaced emissions. So those last two bars are high, the largest ones here, right? And that's really where we stand to gain the most. And so the two things to take away from this, or three things to take away from this figure, I suppose, are one, harvested wood products can be part of the story here. The second thing to focus on the difference between long-lived products and short-lived products is that, right, short-lived products will more quickly be burned or decomposed. The more that we can put more wood fiber into long-lived products, the better off we are. So that's an opportunity area. And then additionally, this importance of substitution. Sorry, slow on over here to move. Wait a second. Okay. So a strong focus here is going to be on construction, right? So especially when we're talking about the importance of substitution, that's really almost exclusively coming from the construction sector, as well as bioenergy, which is more of a disputed category there. But construction sector emission substitution represents the largest potential for wood products in terms of carbon storage. So this is just a snapshot of global construction emissions as they currently stand. This is 2018 numbers. So building and construction materials representing 11%. So that's distinct from, as you'll see, building operations, heating and cooling and so forth. But the materials themselves, the production, manufacture of those materials is 11% of global emissions. 8% of that is coming from concrete alone. So this is currently a huge source of carbon emissions, expected to increase relatively dramatically. So here are a couple of projections showing estimates for a 50% increase in residential construction, 150% increase in commercial and public construction. Those numbers are represented on the figure on the right. That's by 2050, right? Similar projections from Architecture 2030 saying we're going to double the square footage of the global floor area by 2060, right? Adding the equivalent of adding a New York City every month up until 2060. So these are big numbers, right? And if we are going to stick with this 8% of emissions coming from concrete, we are similarly going to double those emissions here, right? So it's already very high. If we stick with business as usual, baseline construction practices, then we are, dramatically increasing our carbon footprint. And so what can wood do to both accommodate increasing demand for development globally, so less of that's in the US, that's global numbers, and not have incredibly high, there we go, emissions. So when we look at the carbon footprint of a building, we generally talk about embodied carbon. So embodied carbon represents all the carbon associated with getting those materials to the building. And so when we're looking at that 11% from the construction, 8% from concrete, that's what we're talking about, is embodied carbon. It's everything from material extraction, production, and then transportation to the construction site. It does not include the carbon stored in the material itself, nor operational carbon, again, that 28% of global emissions, heating and cooling and so forth. So we're just talking about getting the materials to the building and putting them in the building, because that's where wood can be a substitute in particular. And embodied carbon calculations are done using life cycle assessments, LCAs, which is a very comprehensive multi-step technique to assess the carbon impacts at every stage of that life cycle. And it is a long, arduous process that there are experts who focus in just that. And we use those LCA estimates for product-specific embodied carbon for carbon emissions in order to calculate our substitution benefits. So that's why of harvested wood products. So that's why that's so important. So the potential, kind of to recap some of this, but the potential carbon benefits of wood in construction are: one, carbon storage. Again, that 50% of the dry weight of wood it sticks around there. So we have this direct carbon storage. The second thing is this substitution or displaced emissions, especially for concrete and steel. And then also improvements in terms of operational carbon that we haven't yet really talked about, but there is evidence to suggest that wood buildings, especially, this has been studied a lot with mass timber buildings, have improvements in energy efficiency. So it's less energy intensive to heat and cool the buildings, which equates to emission savings over the lifetime of that building. And then additionally, we have this idea that if we promote wood products in construction, so more so than we are now, right? Relative to baseline, we're creating increased incentives to keep forests as forests, which is a huge, it's hugely important for a host of reasons, but from carbon in particular, the greatest carbon loss is going to come from land use conversion. When folks say it's not economical to keep my forest as a forest, I will convert it to a shopping mall, and so forth. So keeping to do what we can to keep forests as forests is very important for continued carbon storage. And so to the extent that incentivizing timber harvest, making that economical, can keep forests intact on the land. And I note here that there is research, I think, needed on this and the mechanisms to best achieve this. It's something that folks talk about a lot. How do we avoid conversion, what's going to best avoid conversion? And there's a lot a lot of folks will say harvested wood products are going to avoid conversion. And it's obviously not always true, right? Landowners are diverse and they hold on to forests for a host of different reasons. And importantly, forests are diverse, right? So some of them are would be inaccessible to conversion. Shopping malls aren't going to pop up everywhere in the world, right? Housing isn't going to pop up everywhere. And so given the diversity of landowners and the diversity of forests, it's unclear what the best mechanisms are to actually keep forests as forests, let's say. And there are a lot of other incentive programs out there, such as property tax incentives, carbon markets, other incentives to keep forests as forests. And as I say, there's a lot of research, I think, needed as to how we want to think about this, actually, because it's used a lot in, I would say, lobbying in particular, and I don't know that we have concrete numbers about how this functions. And then the last thing to note quickly is mass timber benefits. So mass timber is this, one of many new-ish innovative wood products that, is getting a lot of attention, and in particular is of relevance to the construction sector, right? Because this is where we're going to see huge benefits in replacing concrete and steel because of the properties of mass timber that allow them to be substituted for multi-story buildings and so forth, where concrete and steel are dominant. So mass timber benefits are many, all of the above on this list, but additionally they are associated with more efficient wood use. So both in terms of they can use small diameter wood, they don't require the same dimensional lumber that other wood construction would require, and then also their modular factory-based manufacturing leads to less waste in the manufacturing process. So most of this list refers to wood in general, but mass timber in particular has these sort of extra benefits. Limitations of wood utilization for carbon storage are worth mentioning also. And so this is, lest we come away saying, you cut down wood, it ends up in a wood product. This assumption that everything is being used, perfect wood use utilization. This is an important thing to talk about, both because we don't want to overemphasize the role that harvested wood products can play, and also want to recognize the opportunities for improvement, right? So here, so a couple things to note: less than half of the wood harvested actually makes it into dimensional lumber. A lot of it's going to waste products, bioenergy, paper, things like that decompose quickly. So we're losing a chunk of it right away. And there are fossil fuels associated with the harvesting process, which, when we're looking at the net carbon impact, that is a deduction, right, on the carbon impact, a negative. And then residence time for construction is around 50 years, for paper a lot less. So if we look at the figure on the right, you kind of see how the top bar shows an estimate of carbon in the tree, right, before harvest. We harvest, we lose half of that, what are our numbers here, 40% of that. And then when we turn that just from logging residues and wood products that are seen as not suitable for wood production and not economical to remove from the forest. And that won't all decompose immediately, and that's important for soil carbon as well, but a chunk of that will. And so we incrementally, through the process of production, are whittling away at the carbon that's actually going to be stored in those wood products, all the way till the very last bar. We see, if you can even just barely see, a little bottom black bar that shows what is actually remaining in harvested wood products after 100 years, and the rest is in landfills there. So it's already very small. But again, I wanted to bring up this figure again and look at these as opportunities for carbon improvement, right? So our first decrease there in carbon could be improved via logging efficiency, greater wood utilization, right? I mentioned things like mass timber that use smaller diameter wood, and there are a host of other products that are attempting to use some of those residues, and where we can invest energy there, right? We're getting almost immediate carbon savings. The second decrease is from bar 2 to bar 3. So you can't see my cursor, is wood being diverted to bioenergy and pulp as opposed to longer lived products. So the more we can emphasize longer lived products, the more as a primary wood use, the less carbon we'll use in that stage, right? And I say as a primary wood use because, maybe what we should be thinking about wood as having cascading uses, using its best use first, and then potentially, where appropriate, having secondary uses after the life of that product, right? Via maybe burning for energy, or just additional products, or additional uses, recycling of products. After we get to that first diversion, and of course there are limitations to this, right? Not all wood can be used in all ways. And then we have where we can make improvements in mill efficiency. And again, that last one is if we have more products sticking around in longer lived products, so we have greater wood use, wood reuse, sorry, which, recycling of products using salvaged lumber. If we can keep the wood that we have harvested around in products longer, we are better served from a carbon perspective, and the carbon potential of harvested wood products is that much larger. So I want to talk here about substitution, because substitution is, right, as I just in that very first figure, when we substitute for other emissions intensive materials, notably concrete and steel, we get this carbon benefit because wood is credited with, rightfully so, when it's scientifically backed, is credited with that reduction in emissions. So here, life cycle analyses, as I mentioned before, they refer to this very in-depth analysis that seeks to calculate the embodied carbon associated with not only wood products, but we have LCAs for concrete and steel, and leading to this comparative carbon analysis between products. So LCAs reveal that lumber, wood panels, and other forest products used in construction store more carbon, emit fewer GHGs, and use less fossil fuel energy than steel, concrete, brick, or vinyl, whose manufacture is energy intensive and results in very high, substantially high carbon emissions. So I'll talk a little bit more here on how we think about calculating substitution. As you can imagine, it's not a very straightforward process, actually. There are a lot of assumptions that go into it, and resulting in different estimations for what those numbers should look like, what substitution actually looks like. And so the way we can think about substitution, it's for example, use of wood instead of concrete is going to lead to these displaced emissions. Again, wood credited with these negative emissions. How much carbon is actually displaced in this process, right? Again, LCAs and substitution benefits vary considerably because in some cases the methodology differs. Are you looking at extraction, manufacture, and production? That's the gold standard for how one should be looking at this. That's what LCAs are looking at. But if the methodology differs, then the numbers will differ, understandably, and in a way that complicates comparability. But then in addition to that, even if we were using the same methodology, the assumptions about the wood product as well as the alternative product might differ. I'll get a little bit more into that in a couple of slides here, but so much is based on those assumptions about what the counterfactual scenario was, right? If I'm going to be substituting for concrete, I have to have a host of assumptions about where that concrete was coming from, the emissions associated with the production of that concrete, and so forth. Not only so concrete as well as the emissions associated with the hypothetical wood product. All that comes together to create one with the assumptions and with the LCAs to guiding the process. We create this displacement factor. And displacement factor is the reduction in emissions achieved in the amount of displaced carbon per additional unit of wood used, generally in units of tons of carbon. So what that means is that we assume, okay, we harvest an additional, additional 1,000 tons of carbon, right, in wood products, and we assume that's all going toward being substituted for concrete and steel. They get that additional wood product we apply this displacement factor to that additional wood product. Okay, I'll get a little bit more into what that so first, sorry, how we might think about this is, as I say, generally LCAs are showing that wood products are less energy intensive than other products. So similarly, we have assessments here that are looking at the embodied energy associated with housing type to go alongside that, right? So we have on the top right, we have energy emissions associated with a steel house, concrete house, wood house, and just to corroborate those LCA results showing that wood houses will have fewer embodied emissions, and so to the extent that we can build more wood houses and fewer steel and concrete houses, that difference between the two is the savings. The bottom right figure is looking at mass timber buildings, and again you see that the difference between standard buildings and the wood construction in terms of energy saved. So again, that it's only the difference there that would be the substituted carbon. The displaced emissions, the difference between those two bars. So as I say, there is a great variation in what folks are finding in terms of displaced emissions and displacement factors that we would apply to that difference in carbon harvest. And the range of those estimates goes typically from -2 to 15 tons of carbon, and with an average, and that is including some pretty serious outliers in that range. They're not negative. So the average, though, is closer to, as noted here, 2.4 to 3.9 tons of carbon per ton of dry wood used. So that's how much, for every ton of carbon used, we're saving that much carbon via the substitution for these other products. And I won't maybe go into this too much more, as I've already mentioned a chunk of this, but this is looking at some of the different assumptions that LCAs might make about the materials or practices. So again, cradle to gate or cradle to grave, that's what is actually included in your embodied emissions. Are we looking at extraction all the way to the product going to the landfill? Are we looking at extraction all the way to the gate, which would refer not to the landfill, but instead to the building being constructed? There are various stages of the life cycle of a wood product, and what is included is going to have a dramatic impact on the assumed emissions. And then the forest management and harvesting practices that we assume are going into that harvested wood product. We'll get into this in this presentation a little bit later, the importance of sustainable management, right? If you're not assuming a sustainable management, then you have a quite different carbon outlook, right? So the folks calculating an LCA for a product have to assume various things about the management that went into the tree that went into the harvest. Emissions associated with non-wood materials and processing. So for instance, glulam or composite panels are not only made out of wood, they have additional products that are potentially very high, include very high emissions. And so those have to be included in the LCAs. Steel concrete manufacturing assumptions have to be included also. Transportation distances from extraction to manufacture. And here on the figure, we just see an example of a series of different products and where the emissions might be coming from for those products. Again, hopefully I'm not getting too much in the weeds here, but just let's talk a bit about how we calculate it. So part of what I do is I'm involved in harvested wood product carbon modeling for a series of projects. And what we've done, so here we see some of the literature numbers and some of just an example of some of the calculations that we have put together that are very much in line with each other. So a note that displacement factor only applies again to the change. Say if you harvest more than you, if at whatever level, say the state level, they decide to have additional harvest, then the displacement factor that we apply to that additional harvest is going to be applied only to that additional harvest relative to baseline. So it's not, the whole harvest doesn't receive a displacement factor. It's only the difference. Additional harvest gets the displacement factor, and only the percentage of products assumed to go toward either composite panels and sawnwood or bioenergy. Paper, for instance, pulp and paper do not receive a displacement factor because they do not substitute for concrete and steel or other products. And so just there's a lot more that goes into this, but just to look at some of the numbers, I presented some of the averages that we've seen before. On the right, you see low and high estimates for sawn wooded panel displacement factors. We have relatively similar numbers that we've calculated for Maryland and Pennsylvania using regionally specific LCAs and so forth. And so we're getting a little over 2 as our displacement factor. Key assumptions that go into making that the displacement factor and our understanding of substitution are in a lot of cases actually very problematic, and we've done our best to mitigate those, but this is not always possible, and this leads to kind of conflictual numbers. So the first thing regarding substitution for wood products, increases in harvest, we make this assumption that increases in harvest will increase consumption of wood products, right? So again, if we're looking at the state level, we say, okay, you harvest more, we just make this assumption that's going to increase consumption of wood products. Just automatically the construction industry is going to say, oh, great, there's more wood there. Let's replace it. Let's replace steel and concrete with wood, when realistically, there's not going to be perfect. This will not be a frictionless transition, right? All of a sudden, there's a little bit more wood, and we start to build with wood. It's probably impractical, right? Both because construction sector is not one that changes particularly rapidly. Demand may not go in line with that, right? There are all sorts of reasons why we can't assume just the wood is there and therefore it will be used in these new ways. Similarly, not all wood is suitable for construction, right? So you'd have to say you're harvesting the right kind of wood. And then in the opposite direction, as we'll look at some figures here, in the opposite direction, when we assume that there's less harvest, for instance, say in a state is engaged in an extended rotation scenario, or is engaged in just a no harvest scenario, where they're for conservation reasons. The displacement factor traditionally would be credited with negative displaced emissions, which means like high carbon impact, because you assume that if we're going to stop harvesting, you assume demand is going to stay the same, and so as a result of demand for construction staying the same, in the absence of wood products, you assume everyone's going to start building houses with concrete and steel, right? We don't have harvest, so we'll build with concrete and steel, and that's how a traditional displacement factor might be applied, and it's wildly impractical because the reality is that if a state engages in no harvest scenario, folks will buy from the neighboring state more so than they will build a fully concrete house, right? Or they might actually construct less, right? So we have leakage there as an issue. So that's a serious complication that is not typically applied to displacement factors, and that's something that we in my team have toyed with quite a bit, is to come up with the appropriate numbers for leakage, where we can say, okay, no, we're not actually going to give substitution credit there. We're going to assume that there is out-of-state leakage of forest harvesting activity. And then other assumptions that we assume that there is no change in population growth and associated construction demand over time, both because of the population growth, and then also we may assume that there are political and social changes to preferences for size of houses and things like that. Changes in wood use distribution are feasible. So you make this assumption that, for instance, if folks want to make a scenario that says, okay, we're going to divert 20% of our carbon fiber to long-lived products that used to be going to short-lived products, right? You have a displacement factor applied accordingly. The assumption there is that all wood is feasible. It can just be diverted to one place or another, when in reality, pulpwood may not be able to go to long-lived products. And then emissions associated with the counterfactual building product. So the counterfactual building product being the concrete and steel product, you assume that their extraction, transportation, and manufacturing emissions are not changing over time. This is generally what's assumed, and we know that there are advancements happening in those sectors, and so that is also probably not a fair assumption to make. So substitution for bioenergy is another place we see substitution. Assumptions here that are questionable are counterfactual energy mix. So if we're saying that this wood product is going to substitute for coal or for another energy, we have to know what that other energy is, right? If it's substituting for coal, it's credited with some level of displaced emissions. If it's substituting for clean energy, however, it shouldn't receive any substitution displaced emissions at all, right? Because it's not an improvement on the baseline. And so understanding what that counterfactual scenario is really important. Assumptions we make about it going in the future are a key component of calculated displaced emissions. And so the way that we've approached that is for the Maryland numbers I showed in the previous slide, we assume a linear decline in bioenergy displaced emissions until 2040 per clean energy ambition. So we assume by 2040, folks are going to have clean energy and bioenergy will cease to have any kind of a substitution factor. Yes, that's similar to the other one. So that's a host of emission assumptions. Happy to discuss more of those, but these are kind of critiques in the literature. You'll see these are critiques of substitution analysis, and with good reason, right? These are assumptions that have to be made, and they do complicate our ability to have like a clear understanding of the degree to which wood is substituting for other products. I think it's pretty clear that there is a positive impact of wood use, but the degree to which it is positive is unclear, which complicates things for carbon crediting or incentive structures. So just to visualize a little bit of what these might look like, so visualizing scenario-specific displaced emissions and carbon emissions, we can think of these as hypothetical numbers here, stemming from carbon modeling. So if we look at, for instance, at extended rotation and no harvest, these are two different forest scenarios that I've mentioned. If we look at both of them, they're similar in that, though at different scales, they are resulting in lesser harvest, right? Lesser harvest, what does that mean? When we reduce harvest, what are we looking at? So we have reduced forest emissions. So forests, anything on the below zero is a reduction in emissions. Anything above is going to show an increase in emissions. So we have forest ecosystem is resulting in fewer emissions from that pool, right? Because we are not harvesting. Here, we're not harvesting at all. We're really not losing any emissions from that pool. Here, we're harvesting less, and so having fewer emissions from that pool. But we do see increased displaced emissions because we assume that in the absence of harvest, we still need to construct buildings, right? And so because we're not building with wood, we're building with other materials. And so here you see the displaced emissions orange. So when we don't harvest, okay, well, we have to displace it with something else. And the way I mentioned leakage, we also assume so that part of this, the continued demand for construction products is going to be met with out-of-state imported emissions, imported harvest. So we reduce harvest. Sorry, you don't have my cursor again. But if we're looking at no harvest, right, so we see all that solid green, that dark green is reduction in harvest, emissions associated with harvest at the state level. But we see increased in displaced emissions where that demand is made up with concrete and steel. And then that top gray is leakage, where we see that the remainder of the demand is met by out-of-state imports. So that's just a way to kind of visualize what some of those numbers look like. And I'll move forward on this a little bit. But okay, so another key bit of this, as I mentioned briefly, is all of this requires sustainable forest management to have sustainable forest products, right? These carbon numbers are based on the understanding that we're talking about sustainable forest management here. So quickly, we'll just talk about the importance of sustainable forest management and what that looks like. So again, harvested wood products are part of the solution, but only if they're sustainable. And so certification, and importantly, the requirements of certified forest help to ensure that sustainability. It's not everything, we can go further, and also it's possible to have sustainably managed forests that are not certified, right? But it does serve as this signal for sustainable harvest. So climate smart forest economy. Related to this is a targeted approach strategy to increase the climate benefits from forests and the forest sector, one in which forest management, production, and consumption activity restores, not depletes, natural resources, reduces, not increases, emissions from value chains, and safeguards, not exploits interests of smallholder and forest dwelling communities. So this is a global, term that can be used globally to refer to forest ecosystems in all different forms. 4 pillars associated with this climate smart forest economy. First, reducing or removing greenhouse gases to mitigate climate change is a key component, right? Adapting forest management to build resilient forests, active forest management to aim to sustainably increase productivity and provide benefits that forests can provide, and especially substitution where possible. And then fourth, safeguarding against negative social and environmental externalities that can include regarding ecosystem services, as well as social, local livelihoods, and as well as promoting social and environmental co-benefits, right, where we can, along those same social and environmental dimensions, where we can see benefits to society, benefits to ecosystems where possible. So certification facilitates this climate smart forestry and forest best management practices. And again, it's not required in order to have sustainable forestry. And similarly, it may not be going far enough. There's certainly critiques that that is the case. There are also critiques that our transparency about certification and in particular chain of custody mean that it does not have reliable assurances. So there are critiques and so forth, but it is, a great tool and maybe the best tool we have in order to track sustainable production in forest products. How to become certified. So forest owner must follow set guidance, inventory, implementation of best management practices, and monitoring, auditing by third-party verifiers, which is a huge important part of this. Loggers required to complete training and best management practices for that state. And a lot of these best management practices that we'll talk about in a second have direct implications for carbon storage. So I won't go into these in too much detail. Here we see an example of Michigan best management practices, guidelines in general to avoid, minimize, mitigate adverse effects to soil, water quality, and riparian resources. And so not required in all states, but certification can bring more actors into alignment where best management practices are not required, because certification has a lot of alignment with these best management practices. Just a quick snapshot of what we're looking at in the US when we talk about certification. The most common in the US from an acreage perspective is SFI. Second to that is FSC, and then American Tree Farm, which is under PEFC, similar to SFI. It's sort of an umbrella certification body. So you see, this figure is a little bit, it's hard to see what's going on here. It's relatively static from 2011 to 2016, but you see a slight increase in acreage covered by SFI, I think relatively stagnant in FSC, and declining acreage in ATFS. So, but in general, this serves more so to serve as not market share, but similar idea of which certification bodies are more widely adopted. And importantly, this is not, one is not necessarily additional to the other. It's a lot of land that is certified by both SFI and FSC, as one would expect. If you're already engaging in the practices. So kind of in sum here about forest harvesting and certification and best management practices and so forth, there's a spectrum of forest benefits, and a sustainable wood harvest can be part of those benefits, but it is maybe not appropriate in all places, right? It's not appropriate probably in areas of great ecosystem value, biodiversity value, and high carbon storage, places like on the far right side of the spectrum, old growth forests, maybe looking at tropical ecosystems, and where communities may rely on the forest products and ecosystem services that result from an intact forest, right? So in some cases, harvest may not be appropriate. In other cases, they may be, right? Because it all depends on kind of what looking at forests in a very nuanced way and a broad way, right? Not looking at all forests as the same, because they're not, right? And quickly, I'll just mention a couple things on policy incentivization programs that are linked to harvested wood products. A couple of US policy developments here. Some examples, we have C40 cities pledges to ensure that buildings operate with net zero emissions. New York City's Climate Mobilization Act requires retrofits and efficiency gains. So a lot of that's looking at operational energy, operational emissions, as opposed to actually the construction materials. But then the US government's, this is new, ARPAE has $45 million toward supporting development of carbon negative materials and buildings. And again, that negative is going to come from substitution, right? So that is the only way one gets that. And then low carbon construction task force recently announced by the Pacific Coast Collaborative. So it has clean energy and energy efficiency goals, but also I think with the hope of having a promotion of harvested wood products in construction. And then there are other incentives for non-economical harvest that are, I think, interesting and worth noting. And so Arizona has a new policy, which folks may or may not be familiar with, that incentivize, in an effort to jumpstart a forest economy, to incentivize harvest where it's important for reduction of fuel load in fire-prone forests, and yet where that harvest is non-economical. You know, folks aren't signing up to harvest there, and so anyway, the need for government incentive structures as a tax incentive to get more involved in harvest. Many other states have, Wisconsin's managed forest law is another interesting one that has a tax reduction associated with mandated harvest at a certain time, in line with sustainable practice, but with an aim toward maintaining the wood products industry. And here, just sort of a breakdown of, at the building level, if we want to think about how would you incentivize greater wood use in construction, different approaches and current examples of different programs globally attempting to do that. There's a lot of material here. I can send out these slides for folks to peruse a little bit in more detail, but the main policy options I'll talk about are carbon fee, a benchmark target, or a fixed cap. So these could be different ways that governments might seek to either penalize the construction sector for their emissions, which would then lead toward carbon being calculated, part of the calculation in decision making around construction decisions. And so, you know, the idea is that would lead toward greater wood use. And then benchmark target is a similar, benchmark target and a fixed cap are similar ideas that are either mandating some sort of a reduction in emissions associated with construction, again, with the idea that this would lead toward, I don't know whether they were constructed with that idea, but the implication for wood would be that it would increase wood use relative to other products. And they all have their own complications, right? So as I note on the side there, that the carbon fee is the one that's regularly seen as the most technically feasible in terms of how we actually calculate and assign the incentive, but is very politically unpopular. And so the most technically feasible and probably the most supported by economists, and which is not to say that makes it the best, but politically very challenging. So where we go with that, we will see. Carbon credits, linking with harvested wood products with the carbon market. There's a lot of talk about this, and to be determined what will come of it and how that could play out. Just listing here a couple of question marks about how that might look. You know, who would receive the credit for that? Is that going to the builder getting that credit? Is it going to the producer of the timber, you know, the forest producer, where carbon credits are traditionally stored, and how to demonstrate additionality relative to another product, right? How to say, I was going to build with concrete, but now I will build with wood. You know, how do you prove that you have actually switched behavior? There are certain assumptions about that counterfactual behavior that are very challenging, and they are also challenging for forest product credits, but less so, I would say. And would those potential carbon credits include displaced emissions, substitution emissions, you know, which is where, again, that's where you get your biggest carbon benefit. So not including them is going to have a much reduced carbon credit, but including them is based on all these assumptions that are not straightforward. And so I personally feel this is, I'm interested to see where this space continues, but it seems less rife with conflict is what it seems. So we'll see what happens there. And I will end the presentation there and look forward to your questions.